Okay, today we're going to look at a lesson on rational equations. And rational equations are equations that have fractions or decimals in them. And so when you see a rational equation, you often will feel, even as I do, a little overwhelmed, like it looks like a lot of hard work to deal with fractions and decimals whenever we're adding, subtracting, multiplying, or dividing. So what we're going to talk about today is a little tip that can help you get rid of those fractions and decimals in your equations to make your numbers much easier to work with. So when we are working with these types of equations, the best way to solve these is to multiply the entire equation by your LCM. And your LCM is your least common multiple. And so that's the least common multiple of fractions and decimals. So least common multiples of fractions are always the least common denominator. So you look at all the denominators, find the number that they all go into. The least common multiple of decimals, though, is going to be a power of 10. So 10, 100, 1,000, and so on. And we'll look at that with some examples. So in other words, we are going to multiply through by our common denominator or multiple, whether we're dealing with fractions or decimals. So we're going to multiply our entire equation by a certain number, and when we use the right number, it will make those fractions or decimals go away. One extra little tip, though, is anytime we see an opportunity to distribute, we need to make sure we do that first. So here's our first example. It is a rational equation. We have some decimals in the equation. You'll notice both of our decimals go out to the tenths place. So if you read your decimals properly, 2 and 8/10, 1 and 3/10, that tells you what place value it's going out to. And that also tells you the multiple of 10 to use to multiply your equation through. So if they both go through to the tenths place, that means if I multiplied 2.8 by 10 and 1.3 by 10, they would turn into 28 and 13, therefore getting rid of our decimals. Now we can't just multiply the decimals by 10, we have to multiply the whole equation by 10. So what I'll do is put a big parentheses around my whole equation, or you can show it like this. You don't have to show both of these steps, you'd pick either or, and showing that the 10 will eventually multiply to every single term in your equation. Your terms are values separated by addition, subtraction, or equal signs. So when I multiply 2.8 by 10, it becomes 28. 5 times 10, we move that decimal one place, becomes 50. 1.3 times 10 becomes 13. Now, I don't know about you, but to me, this equation looks much nicer to deal with than this one. We've got some nice whole numbers, and from here, we just solve for n as usual. Subtract 28 from both sides. So you get 50n equals negative 15. Divide both sides by 50. And reduce. So it reduces to negative 3/10. When you get your value for n, I'm going to discard these changes. When you get your value for n, or any variable you're solving for, it is often helpful to then go in your calculator and check that that's the actual value. So I'm going to walk you through a couple tips about your calculator. So whenever you're on your calculator at your home screen, you can go to the scratch pad to calculate something. So when we have, let me get to where we were, n is negative 3/10, we can write that fraction in our calculator. I'll show you that in just a moment. Just a little side note here, if you were to get a mixed number, if you had to type in a mixed number in your calculator, there's actually a lot of things you have to do that. Remember, a fraction or a mixed number is really 3 and 1/2, and that and means add. So this is really 3 plus 1/2. So if you were to type 3 and 1/2 into your calculator, you have to use parentheses and a plus in the middle, and the negative has to go outside. So really what I prefer is that you just convert this to an improper fraction and always type fractions into your calculator. Improper fractions into your calculator. So let's check this value for n. So we got n to be negative 3/10, and when you get your value, you always take that value and plug it back in for n to see if it makes your equation true. Well, our calculator can do that for us. We can type the fraction negative 3/10 by doing a negative. Make sure you use this negative, not the minus sign. Then if you hit control division, it brings up your fraction bars, and do 3 down over 10. Then arrow over to the right, so arrow out. What we want to tell our calculator to do is save -3/10 as n. So tell the calculator that n represents -3/10. So we're going to be storing this value as n, and the way to do that is to hit, we want this light blue store. That's what we want. So to get to that, we're going to hit Control. Control tells it to get us the light blue stuff, then the variable button to get store. And it should give you this arrow, and then we want it to be n, so we choose n and hit enter. If you've done it properly, number first, store variable, then it comes up and shows you, okay, n is now 3/10. So if I were to type n and hit enter, you can see n's value is -3/10. But the cooler way to check is now, all we have to do is 2.8 plus 5n and hit enter and see that we do in fact get 1.3, which is what it was equal to. So please use that store value in your calculator at any time to check your work. All right, let's move on to example 2. So here we have another rational equation, this one with fractions. So instead of multiplying through by powers of 10, we're going to look at our common denominators, 2, 3, and 7, and look for a number that goes into all of those. No, I'm making a video, sorry. Okay, and so we want to look at 2, 3, and 7. And the least common denominator of those numbers is 42. So we're going to choose 42 to multiply our whole equation through by. That means we're multiplying 42 by 1/2 n, 42 times -2/3, and 42 times -5/7. You can stretch it out like this. You do not have to. I kind of like doing this though, just because it makes multiplying the fractions a little bit easier. Remember, these are really all 42 over 1. And so if we do this multiplication correctly, all of these fractions should become whole numbers. So let's try this out. If I do 42 times 1 over 1 times 2, it's really 42 divided by 2, which is 21n. Another way to think of that is you can cross cancel the 2, and then you're left with 21 times 1 up top. So here let's cross cancel 42 and 3. Okay, so this one will give us 14 times 2, which is 28. And here when we cross cancel the 7s, we're left with 6 and 1. Okay, so really it's 6 times -5. So you should get 21n minus 28 equals -30 if you do all that multiplying correctly. From here, again, this equation looks so much cleaner to work with than that first one we were given. And add 28 to both sides, divide by 21. So we get n equals -21, or 2 over 21. You could certainly store this as n, type in that equation, hit enter, and make sure it says true or that you get the same value on both sides. One little side note that I want to make here is that we're multiplying everything through by 42, and this is actually a property of math that allows us to do this. Because we're multiplying everything on both sides by 42, we're actually not changing the equality. While our numbers change, the sides remain equal, because if I'm multiplying both sides by the same value, it's going to still be equal. So if I had 2 equals 2 and I multiply both sides by 3, then I get 6 equals 6. The equality is still there. So that's why we're allowed to do this. Okay, here's another example with fractions. So what I'd like for you to do is work this one out on your own. You can pause the video, and then when you're done and ready to check, click play. Okay, so we're checking this equation. We should have had n equals 95/8. I really like for you to just leave your fractions as simplified improper fractions instead of taking the time to go to mixed numbers. Like I said earlier, it's hard to type this into your calculator. So just leave it as improper mixed. You can give me that as your final answer. Here's another example. This one has an extra step at the beginning. Notice the big parentheses mean to distribute. So you must distribute first. And this is the only time where you're going to have to deal with actually multiplying a fraction by something. This one's not too bad. 5 times n is 5n. 5 times 1/2 is 5/2. So you have to distribute. Now that we've distributed, you carry on as we've done all the other problems. So multiply through by your common denominator and solve for n. So again, let's pause the video. I'll let you pick up with here and carry on to solve for n. Okay, so now you're done and ready to check. I multiplied by 30 all the way through. If you chose 60 or something larger, that's totally fine. You just would have bigger numbers and you would just simplify at the end. We should all get to the same place. So I carried on to this slide. So we should have gotten n to equal 133 over 150. Here's another example with decimals. Note that we've got some distribution that happens. I want you to work this one out so you can pause the video, and when you're ready to check it, click play again. All right, so we're going to check example 5. Distribute first. Again, you have to do 2 times 0.7, which is 1.4. Now we multiply through by 100 because this one went out to the hundredths place. Everything gets multiplied by 100, giving us what you see here. Don't forget to do it by 2 as well. Start solving for n and isolating n equals -2 over 65. And lastly, we'll finish up with equations that have both fractions and decimals in them. And when you see these types of problems, you need to pick a format to transform those into. So if I have decimals here, I might want to convert 1/8 to a decimal, or I could convert my decimals, 1 7/10 and -5 6/10. I could convert these to improper fractions. So this one is 17/10. And this one, we could reduce this 6/10 to be 3/5 right there. And then do 5 times 5 is 25, plus 3s are 28, so this is -28/5. Okay, and so then from there, you would set up your equations using all fractions or all decimals. You're going to see that I almost always go to all fractions. So I would write this equation, set it up as 17/10 minus 1/8 n equals -28/5. Then I would multiply through and go from there and solve for n. You can do this on your own. You should get n to equal 292/5, okay? But I want to talk about why I always or almost always convert to fractions. And the reason for that is actually in this equation. Notice that in this equation we have the fraction 1/3. Now 1/3 is a repeating decimal. If you try to convert 1/3 to a decimal, it'd be 0.3 repeating. Well, we have this one as a decimal, so you might think, well, let's just convert this fraction to a decimal and then we'll multiply through by 10 or 100. However, the problem becomes that we cannot write that whole fraction on our paper as a decimal. It goes on to infinity. So because of that, you actually have to convert 2/10 to that fraction. This one you have to convert to fractions because of the repeating decimal that would be created by 1/3. So we can use 1/5 and then solve from there. So here you would get x to equal 78/5. And again, you could work through this on your own. You'd multiply through by 15 here, and over here multiply through by 40 and carry on. So when you see a mix of decimals and fractions, choose your preference. Either transform every fraction to a decimal, as long as none of them are repeating, or all decimals to fractions. And then you just solve as usual. So hopefully this helps you more easily solve rational equations this unit or this year without having to always jump to a calculator and potentially make errors in your calculation. So today we went over how to enter a fraction in your calculator and how to store a value in your calculator as well. You can always rewind and go back to that part of the video. There is an extra practice problem. Take a moment, work it out. When you're done, you can click play to check it. All right, so to check this one, should have multiplied through by 12. Again, if you chose 24, that's fine. You just would have more reducing at the end. Combine your like terms. So here I subtracted 2n from both sides to combine the n's. Here I added 15 to both sides, and n should equal -7/26. That's all we have. Thank you for watching the video.